Ever felt a tiny tremor under your feet and wondered what's happening deep within the Earth? Sometimes it's just the planet stretching its tectonic legs. But other times, it's a sign of something far more dramatic. Today, we're diving deep into a fascinating and slightly unnerving phenomenon: volcanic swarms. So, what exactly are they? You've probably heard of earthquakes, those single, powerful jolts. A volcanic swarm is different. Imagine not one, but hundreds, or even thousands of small to moderate earthquakes happening in the same area over hours, days, or even months. It's like a seismic drumroll, a rapid-fire sequence of tremors that don't follow the typical mainshock-aftershock pattern. Instead of one big event followed by smaller ones, a swarm is a relentless, ongoing conversation happening miles beneath a volcano. To understand this, let's picture a normal earthquake. Tectonic plates get stuck, pressure builds up, and then boom. The pressure releases in one major slip, the main shock. After that, the surrounding crust adjusts, creating smaller aftershocks. A swarm, however, isn't usually about tectonic plates slipping. It's about magma on the move. Think of it like this. You have a bottle of soda. If you shake it, the pressure builds up. Now imagine that pressure isn't released all at once. Instead, tiny cracks start to form in the bottle and gas and liquid begin to force their way through. Each time the fluid moves and fractures the rock, it generates a small earthquake. That's a volcanic swarm. It's the sound of magma, gas, and superheated water pushing their way through the Earth's crust. A classic example happened in Iceland on the Reykjanes Peninsula starting in late 2023. For weeks, the ground was rattled by tens of thousands of earthquakes. This intense swarm was a direct result of magma accumulating in a dike, a vertical sheet of molten rock just beneath the surface. The constant shaking was the sound of the ground cracking and shifting to make room for this intrusion. And as we saw, this activity was the prelude to several eruptions near the town of Grindavik. The swarm was the volcano clearing its throat before it spoke. Similarly, before the 2018 eruption of Kīlauea in Hawaii, scientists observed intense earthquake swarms at the summit. This wasn't just random shaking, it was a clear signal. The lava lake at the summit was draining, and magma was moving underground through the volcano's plumbing system. The swarm tracked the magma's path, basically drawing a map of where the pressure was headed. Days later, fissures opened up miles away in the Leilani Estates neighborhood, exactly where the seismic activity had migrated. The swarm was the ultimate heads-up. So, how do scientists know it's a volcanic swarm, and not just a weird series of regular earthquakes? They look at a few key things. First, the location. If the quakes are clustered directly under or near a known volcano, that's a huge clue. Second, they analyze the seismic waveforms, the fingerprints of the earthquakes. Swarm earthquakes often have a different character than tectonic ones. They can be what's called low frequency, which suggests the movement of fluids, like magma or gas, rather than the brittle fracturing of rock. Third, and most importantly, is the pattern. No clear main shock. The quakes just keep coming, sometimes increasing in frequency or intensity over time. Scientists use an instrument called a seismograph to record this activity. When you visualize the data, it doesn't look like a single spike. It looks like a dense, chaotic scribble, a visual representation of the Earth's underground restlessness. But an earthquake swarm doesn't always mean an eruption is imminent. Sometimes the magma moves around underground and then just stops. It cools and solidifies without ever reaching the surface. This is called a failed eruption or an intrusion. The swarm eventually dies down and the volcano goes back to sleep. For instance, the long Valley Caldera in California has experienced numerous intense swarms over the past few decades, causing a lot of concern. But so far the magma has stayed put. This is why monitoring volcanic swarms is so crucial. It's a puzzle. Scientists at observatories like the USGS Hawaiian Volcano Observatory or the Icelandic Met Office work 24/7, analyzing this data in real time. They combine seismic information with other clues like ground deformation. Is the ground swelling or sinking? They also measure volcanic gas emissions. Are gases like sulfur dioxide, which are dissolved in magma, escaping to the surface? When all these signs point in the same direction, a swarm of low-frequency earthquakes, ground swelling, and increased gas emissions, the alert level for a volcano is raised. It's this combination of data that gives us the power to forecast. It allows authorities to make informed decisions like evacuating towns, closing airspace to prevent jets from flying through ash clouds, and preparing emergency services. Think of volcanologists as detectives, and a volcanic swarm is one of their most important pieces of evidence. It's a direct message from the planet's molten heart. While most of the Earth's inner workings are hidden from us, these seismic conversations give us a rare chance to listen in and understand the immense forces shaping our world from below. They are a powerful reminder that the ground beneath our feet is not static. It's a living, breathing system. So the next time you hear about an earthquake swarm near a volcano, you'll know it's more than just a little shaking. It's a potential sign that something big is brewing. It's the Earth's own early warning system, a rumbling truth that commands our respect and attention. Thanks for joining me on this deep dive into the world of volcanology. If you found this fascinating, make sure to hit that like button, subscribe for more adventures into our planet's secrets, and ring that notification bell. Let me know in the comments if you've ever experienced an earthquake. Stay curious, and I'll see you in the next video.